here's another video to help with some of the review stuff with all the snow and cold days we've had. So hopefully you're staying warm and cozy. All right, so this unit actually isn't too bad. So if B varies directly, that means that your K is always your constant. It's always in the numerator no matter what, because, you know, I mean, if it's a half, you could write a half, or you could have something divided by 2. I mean, those are really the same, so we might as well just always keep K in the numerator. So, you know, so half X is the same as X divided by 2. So we just go ahead and keep K in the numerator no matter what. But that's your constant. So B varies directly. That means it's all on the same level with the square of T. And usually what happens is they will tell you T and B, you'll solve for K, and then you'll use it to solve something else. It's usually like a 3-step process. Y is inversely, okay, so again, K is always in the numerator no matter what, because again, it might be a fraction if we want it to be, but it varies inversely proportional to the cube root of, what is that, R? So the cubed root of R is going to be down here. So it's an inverse relationship. R varies jointly as what? T and U. So these are kind of glued together. So R varies jointly. So R, and we have a K, and then again T and U are right there. M varies directly. Okay, so M. So varies directly. You know, varies is your equal sign here. All right, so M varies. Again, you always need a constant. Directly with the square of n, not square root, square of n, and inversely to P. So again, directly means as one goes up, the other goes up. Inversely means as one goes up, the other goes down. My best example would be like the more people you have shoveling the driveway, the less time it takes. That's an inverse relationship, because as workers go up, time or work even goes down. Okay. Other things are directly proportional, like the more let me think. Oh gosh, usually more things are directly. I don't know. The more I buy, the more it costs, right? If I buy 2 cans of soup versus 200 cans of soup, the more I buy, the more it costs. Okay. All right. Let's look at the next one. Write an equation. That variation. Okay, so N varies jointly with P and Q. So again, we need a K and we need P and Q. And let's see, N is 72 when P and Q are 2. So K equals, let's see, 3 times 2 is 6. So I'm going to divide both sides by 6. So K is what, 12? So again, I write my formula. They're going to give me stuff to sub in. Great. I sub it in, and 3 times 2 is 6. So that's why I divide both sides by 6. And I get what? 12. So then what can happen is you can rewrite the formula so that you can use it to solve other problems. All right, let's look at this one. Y varies directly. So again, K's are on top regardless. Directly with X. So X is on top because of the word directly. Inversely with Z. All right. So the next step is they're going to give you stuff to solve for K. So let's solve for K. 32 equals K, which is our constant of variation. We get a 4 and we get an 8. So if I keep solving that, 32 equals, was it half K? To get rid of half, I'm going to double. So it looks like what? K is 64. All right. So then the next step would be to rewrite your initial formula. So Y equals 64 X over Z. So now I know my constant, and then they're going to give me some other numbers to solve, say for Y or Z or whatever. Same thing here. Let's see, W varies. Again, we always have our constant inversely with Z squared, not square root, squared. Again, sub in what you know. W, I don't know K, I know Z squared, 3 squared. So then I know what? 3 equals K over 9. To get rid of dividing by 9, I'm going to multiply by 9. So what is that? K is 27. And again, to write the general formula, I would go, well, let's just go over here. Go back to the beginning. W equals, what is it? 27 over Z squared. Okay, and then I could, solve some problems for there. All right, let's look at the next page. Okay, so let's see. I don't know. Let's do number 12 here. Y varies. So again, y varies. Again, there's always a constant inversely as x. Okay, so inversely with x. Okay, next step. They're giving us some values so we can solve for k. All right, so what do we have? 2k, 8. To get rid of dividing by 8, we're going to multiply. Looks like k is 16. So then we can sub that in to get our formula. Y equals what? 16 divided by x. Great. But then they're going to say, okay, find x when y is 14. So now we're actually using our new formula with k in it to solve for one of these variables. So they're saying y is 14. So they're giving us the output, and they want us to solve for x. So first of all, I'm going to get the x in the numerator because we don't like fractions, right? So let's get rid of that. So we get 14x equals 16, divide by 14, and x is what? Is that 8/7? Looks like it. Okay, something like that. All right, let's see. Let's look if we can do a story problem here. All right, so let's look at number 2. So I'll give you a minute here. Try to just set that up. All right, and I'm actually going to pause a little bit, okay? So the time required to process a shipment, varies directly with the number of goods and inversely with the number of workers. If 15,000 items can be processed by 8 workers in 10 hours, how long would it take 12 workers to process in 20,000 items? All right, if I could read, it would help. All right, so see if you can set that up. Like, do you want one equation? Do you want 2 separate equations? How is that all going to work? So you try setting it up, figuring it out, and I'm going to pause and then we'll come back. All right, so first of all, we have to read carefully. Time required, so time, okay, varies is my equal sign. There's always a constant. Varies directly with the number of goods. I used n for that, and inversely with the workers, okay? Then it tells me that 15,000 items, they tell me my workers and my time, so I sub those in. We don't like fractions, so multiply both sides, and then to solve, I divided. And I just reduced this on a calculator, so I just took, 80,000 divided by, 15,000, and then I went, switch to fraction key there, okay? So it just converted it for me. So I got that. And again, instead of writing it like up in the numerator, I just kind of wrote numerator, denominator here. But this is your k value. All right, and then n and w and t. So you just sub in your k. And then now it tells me, okay, well, you have 12 workers, you have 20,000 items, and what else? How long would it take 12 workers, okay, and to process 20,000 items? So I have 20,000 items and workers. So I'm actually solving for output here. I'm solving for t. So I just type everything in, and I get that. And again, on a calculator, make sure you group and group so you can do that. Now, if you're not sure if that answer seems right, we can do problem solving. But this took me a little while. Algebra is beautiful. This is just like so quick. Problem solving, not so much, which is why algebra was invented, because it is the best problem solving. All right, so what I did is I made a nice little chart. So let's think about it. If I go down to 1 worker, okay, so if I divide, and you can only kind of do 2 at a time because our brain doesn't like to do all 3. So if I have 1 worker, obviously, and they work 10 hours, they're only going to be able to do 1/8 of the items, okay? So if I get down to 1 worker, these are going to be divide by 8, divide by 8. So I get this, okay? So then I want to go up to 12 workers, okay? And again, you can only use 2, so I'm going to leave this guy the same. So if I have 12 times as many workers, it should take less time to get the job done because those 12 workers can do this faster. So that would be inversely. So 10 divided by 12 is 5, 6. Okay. So then I got this number where I wanted. Now I needed to get this up to 20,000. And so what I did is I took 20,000 divided by that to see kind of what the relationship was. So again, I just took 20,000 divided by, 1875, enter. And again, if I go to convert to a decimal to fraction, I knew that relationship was 32 thirds. So if I'm making this one 32 thirds bigger, okay, I'm leaving my number of workers the same. I'm just adding more items to deal with, then the time should go up, right? It should take more time because I have more items. So if you multiply those two fractions, you end up getting that, which is exactly the same as what we got with algebra. And again, the algebra was so much easier. Okay, problem solving is great, right? But we really have to think like, are these inversely? Are these directly? What's going on? Here, you just read the English language. And again, it can be confusing. So you got to kind of pull it apart, write your equation with variables, sub in what you know, solve for K, and then you just sub it in. It's so slick. All right, why don't you try, I'm trying to think which one should we do next. Oh, I don't know. Try number 3. And again, this is how these typically look. So read number 3, just pause it, try to set it up yourself, try to solve for K, and then try to use that equation to do the next part. And again, I'm going to pause this. Okay, I ran out of space on the paper, so I ended up writing it here. But let's read it. It says the maximum load, and again, always the constant. And then it says varies directly with, oops, it helps if I have the right one. Sorry. All right, let's go down here to when I ran out of room. All right, so the maximum load supported by both ends varies jointly with width and the square of the height. So width and here it's great, and that's jointly. And then divided by, so inversely with the length, okay? And so then what I did next, and again, I tried to mush it on here, but I ran out of room, is I went ahead and subbed in the width, the height, and the maximum load, okay? And the length of the beam, and I solve for K. And again, that's always, and make sure order of op, you multiply, or do the exponent first, then multiply. And I went ahead and divided. You could multiply both sides by 6 and then divide, that's up to you. All right, so I got a K of 6 million, okay? Then it has you solve a different problem. What is a maximum load supported by a beam that long with that width and that height? And so now that we know K, we can do that. So I came over here, here's my formula with a K in it, subbed in my width, subbed in my height, the length of the beam, and I just did order of op. And again, it's probably, aren't that's most scientific, you have the nice fraction bar. Otherwise, I do order of op, so exponent first, then multiply, I got that number, and then I went ahead and multiplied these two numbers and divide by 16, and I got a load of that, which seems reasonable because the initial load was 360 kilograms. So, you know, it makes sense, at least in my mind, that, you know, that might be the appropriate load. At least it's in the ballpark. All right, so that should help with those. Again, those aren't too bad. There's some that talk about symmetry. So obviously, if you have like y equals x squared, you have symmetry. Well, it helps if I draw a nice x-axis. You have symmetry to the y-axis, okay? And you can just kind of look. If I sub in a negative x, that's the test. If I get back to what I had, it's like, oh, wow, these are the same. This is called an even function, and it has symmetry to the y-axis, okay? If I have something like y equals x cubed, right, and if you graph that, 0, 0, 1, 1, negative 1, 1, this kind of does a little disco-y thing. Something like that. If you look at this, if you sub in a negative x, where the x used to be, a negative times a negative times a negative is still negative. And so you notice it's the opposite of what it used to be. It used to be that, now it's the opposite. So if it's the opposite, that starts with an O, opposite and odd. This is an odd function. And the word origin also starts with an O. So this has rotational symmetry around the origin, like if you rotate it around that. So that's another type of symmetry. Some things are symmetrical to the x-axis. You can just graph those and look at them. We usually don't care too much about them because they're more like that formula. And notice this fails the vertical line test, so it's not even a function. And pretty much this whole class is about functions, so we really don't care too much about those. But to see if it's symmetric, you can always graph it. We'll do more with even and odd as we get going. So, all right. Hope you're doing well. Stay warm and cozy. Hope this video helps you.